the plate is cooled not only from this edge but also from the top surface and bottom surface. Here is the small portion of the plate. Well, again, we have specified the boundary conditioning and the cooling only from the side surface, which is very small comparing to the top surface and bottom surface. In fact, this problem requires the three-dimensional analysis, but we can simplify the model. You see the temperature difference between the top and bottom surface is 0. We can believe that the temperature distributed uniformly from top to bottom. Now the top surface is cooled by the convection heat flux, which is denoted by this equation, and by the radiation heat flux, and you can see this equation. To simulate this problem in two-dimensional, we can substitute the heat flux that is taken away by the convection and heat flux that is taken away by the radiation with negative volume heat source. Volume heat source is heat flux divided by the volume, and if we substitute the heat flux with the convection heat flux and the radiation heat flux, we will get the equation to calculate the volume heat source. Now let's take a look at the calculation I done with the Excel. I have here the temperature. Here is the ambient temperature, again in kelvins, which is 20 plus 273. Now alpha coefficient is 10, beta coefficient is 0.8, the plate thickness is 1 micron, and this is the equation to calculate this part. Alpha multiplied by the temperature difference and divided by the plate thickness. And this is the equation to calculate this part, the heat flux through the radiation. This is the temperature difference, temperature in 4th power minus ambient temperature in 4th power, again divided by the plate thickness and multiplied by the beta coefficient and Stefan Boltzmann's constant. And this is the volume heat source, which is just the sum of convection and the radiation heat fluxes. And here is the temperature calculated in Celsius degrees. Now remember that we have two surfaces, top surface and bottom surface. And the heat flux I should multiply by 2. So in QuickField, for the copper, to take into account the convection and radiation from the top and bottom surface, I specify virtual volume heat source. You see what is the physical meaning? The higher the temperature, the more heat is taken away from the surface. Now again run the thermal simulation.